In today's video, I'm going to talk to you about soil carbon, why it's important, and tell you some of the things you need to know about it. We all know that lots of carbon in the soil is good, isn't it? But when we consider how depleted our soils are, it becomes even more important. And everything on Earth works on the basis of this magical equation called the C and N ratio. This C and N ratio is absolutely crucial. Most things tend to operate in a state of equilibrium at about 10:1. And if you go too much above that in terms of soil, it can actually slow down the mineralization process. So that means it actually takes longer for key nutrients to get to your plants through their roots. And this mineralization is driven by the breaking down of soil organic matter, the conversion, which is carried out by microbes, which I talk about all the time. So if you have too much carbon, it actually slows the rate at which that conversion happens, and so those nutrients are much slower at getting to the roots of the plants that you're growing. It's also worth saying at this point that if there is too much inert carbon, so if you apply raw carbon effectively, you could throw coal and all sorts of other things into the soil. That is not necessarily good as well. It can detract from the soil before it ultimately releases. And this is why in certain practices, for example, the application of wood chip in certain scenarios is best done as a soil dressing rather than combining it with soil such as is traditionally done with things like composts or manures. Applying it to the surface allows it to naturally reach that state of equilibrium and then slowly begin to break down and incorporate with the soil naturally in a slightly different form that gives rather than takes first. But carbon is actually divided into two main fractions: the inorganic carbon and the organic carbon. And the inorganic, or the inert, is the total carbon taking away the organic fraction, and it's this organic fraction that we're going to concentrate a little bit on now. Now, the organic fraction is not a constant. It is constantly changing due to the unique interactions with soil, plant roots and soil life again. So we should consider the cycling of carbon over time, perhaps a little more than just measuring carbon at a point, a fixed point in time, and again in the future. It will be doing this throughout the season, throughout the years, rather than just starting here and increasing or decreasing in a very linear fashion. So organic carbon can be split down again into different pools, and the first of these is the labile or active carbon, which means that the particulates have been almost entirely decomposed and are readily available as a microbial food source. So that means they can be chomped on and turned into essential foods for your plants and crops. Now, the next of these pools is the humus carbon, and experienced growers, people who are really into their soil and compost production, will know all about humus. This is the decomposing carbon. It's pretty stable, and it's often really why we seek to have high levels of humus in our soil, because it is a stable form of carbon, and it's often made up of all the plant residues, all the soil organic matter, the more complex change of carbons of things like wood chip and manures, natural kind of waste products that are incorporated into the soil, reduced down or in the process of reducing, and are in a lovely stable form. Now, the last of the organic kind of carbon pools is the recalcitrant carbon, and that's the very kind of tough, difficult to digest carbon pool, so resistant to decomposition, and it could be a component of a material such as biochar or charcoal, for example. It's the bit which lasts and stands the test of time. Now, just on humus again, if you're interested in understanding a little bit more about modern thinking on humus, because some of these principles are actually quite old, I would definitely suggest checking out an earlier video which I made, which talked about the kind of increasingly up-to-date scientific thought process on humus in the soil. I will link to it at the end of this video, so if you want to find out more about that, click on that video. It's probably also a good time just to say, if you like videos like this, like learning about soil so that you can grow better food that's healthier and tastier, then do please give the video a like and consider subscribing to the channel. That way you'll be notified whenever I post a new video. But let's get back into it. Now, carbon, as I've alluded to, is incredibly important as a driving force behind soil life, and that includes microbiology, so the bacteria and fungi that will help mobilize things to our plants and crops that we're growing. And soil carbon is not the same thing as soil organic matter. We can think of soil organic matter as containing carbon as well as a whole host of other things. It's a very broad term, whereas soil carbon is precisely that. It is specifically focused on this one particular element and the different forms in which it's available. And it's this bit which is really kind of capturing the imaginations of farmers and growers as well as governments across the world, because it is seen as an incredibly useful tool which people should be rewarded for increasing, because it helps to offset some of the impacts of climate change by capturing that atmospheric carbon and incorporating it into the soil. So just to finish by closing, I mentioned earlier that carbon is constantly changing, or should be in an active and healthy soil, constantly changing throughout the year, and it's a really good idea to get a measure of precisely where you're at and perhaps how some of those fluctuations occur. And the way to do this is through a soil test. This is something that you can do very simply yourself with the help of a laboratory. It's not particularly expensive, but I would definitely recommend, if you're serious about growing, get a soil test done and make sure that you are incorporating a measure of soil carbon. That way, in the future, you can always look back at this particular baseline and know whether you are actually building reserves of carbon in the soil in the long term, or if you are depleting. And you definitely do not want to be depleting your soil of carbon, because that is the driving force for all those interactions that help support whatever you're growing. So there we go, that wraps this video up. Hopefully it shed a little bit more light on the subject of soil carbon. If you liked it, please do give it a thumbs up and consider subscribing to the channel. But for now, let's crack on, and I look forward to seeing you in the next video.